Today we're doing square roots involving variables. So when I give you a statement like x, the square root of x squared equals x, if I were to substitute that 3 in, remember x is always going to be 3, so I'd substitute it for in both sides of the equation. And I end up with this 3 squared is 9. Is this a true statement?
Yes.
Yeah, we get 3 equals 3. Well, what happens when we put a negative number into that statement? Does it work? 3 squared, negative 3 squared is, negative 3 squared is 9. Is not the square root of 9 equal to negative 3?
No.
No, because there is no two numbers that you can multiply that will give you a negative number. Okay? So because of this situation, we account for it in a special way. We're going to use the square root of x squared is equal to the absolute value of x. Now let's try a negative number. Negative 3 squared, the square root of negative 3 squared, is that equal to the absolute value of negative 3? Well, the root of 9 is what? 3. And the absolute value of negative 3 is 3. Does this work?
Yeah.
It's a true situation. So really, when you have x squared equals x, it only works for non-negative numbers. Okay? So in order to account for those negative numbers, okay, we've got to use this absolute value of x. Okay, so we're going to look at, this was the first statement we started with. The square root of x squared is equal to the absolute value of x. We've determined that this is a true statement, right? So now let's keep going. We're going to start to create a pattern. So let's look at x cubed. X cubed is really made up of x squared times rad x. And we call this radical. Short, we could say rad x or rad x squared. Okay, what is the root of x squared? X. And I can't take a square root out of this portion, so I just have to leave it in that rad because it's not a perfect square. So now because I have something else to multiply it by, when I pulled that out, I don't have to worry about that negative. Does that make sense? Because there's going to be another result to multiply it. If there's a negative times a negative makes a positive. So in this one, when I got it, there was nothing else. If it's negative, there's nothing else to multiply it by. So we've got to account for the absolute value. I mean, we've got to account for that negative number by using the absolute value. Okay, what would the square root of x to the 4th be? Jack?
It would be x, rad x squared,
Rad x squared, or rad x to the right. It makes rad x squared times x squared. And what is the root of both of those?
X for both.
And so what's my final answer?
X squared.
X squared. Okay? Notice it's an even number. It's less evident here. Let's keep going. Okay, the next one. X to the 5th. Now, what we're going to do is we're going to go to the closest even number. What is the closest even exponent? Less than. X to the 4th times rad x. We always go down. Okay, x to the 4th times rad x. What is the root of x to the 4th? X squared, and then I have that other rad x. Okay. Questions? Okay. Next one. X to the 6th. Okay. What do you think this one's going to be? Nadine?
X to the 4th.
Agree?
Oh, no, sorry.
No, sorry, what?
Well, it can't be x to the 6th because it's not the 6 is not a square.
Yes, it is. What's wrong with this answer, Peter?
You need to put
Yes, we need to put it. You are right. We actually don't take the square root because remember, if I had something like this, any number times itself, isn't that equal to x to the 6th? So when I'm pulling a root, I'm looking for what number times itself. Remember, we add exponents. So really, when you see that exponent in there, we're not taking the root of 6, we're just dividing that 6 by 2. What you were missing, Nadine, so you'll notice here it's divided by 2, here it's divided by 2, because every 2 make a perfect root. But what you're not seeing is that when we have an odd result, look what I did. Okay, what would the next one be? Jacob? First break it down to?
X to the 6 times x.
Times rad x.
And
Then?
You simplify the x to 6, which is x to the 3rd, times x.
Times rad x. It stays in there. You guys with me? Okay. Next one, x to the 8th. Nadine.
X to the 4th and x to the 4th.
X to the 4th. Why is this not in the absolute value?
Because it's even.
And anytime you have even, you have two negatives multiplied times each other, it will take care of that negative. What would the next one be? Okay, how about Jacob Thies?
First, would you do x to the 8th
Uh-huh. Times rad
times rad x,
and
and it would go to x to the 4th
times
times x.
rad x. Keep it in the radical. Okay, next one. X to the 10th. Jack.
Absolute value x to the 3rd.
Okay. Next one. X to the 11th. Kate.
Would you do x to the 10th? Oh, sorry, rad x to the 10th rad x,
Yeah?
which would be x to the 5th rad x.
Yep. Okay. Next one. Vivian.
What you would do is it would be x to the 6th.
Yep. Next one. Sophie Welsh.
Rad x to the 12th rad x. Then x to the 6th rad x.
X to the 6, rad x. Good. All right. So now tell me what the pattern is. When do I use the absolute value? At what point? Cheyenne.
When the exponent is odd.
When the what?
Exponent is odd.
When the result exponent is odd. And there's one more piece to this. And when else? When do I put it in absolute value? Jacob? What? Okay, Harrison? No. Yes.
X is odd. When x is negative.
No. Jacob?
Every 4.
No, because we're not going to know. We're not going to write this whole pattern out. Okay, we said, what power is this? This is the first. So we said when the result is odd and there's nothing else left to multiply it by. Do you understand that? That's when I apply the absolute value. Whereas you can see here I have an odd number, here, but there's something else to multiply it by. Does that make sense? So the only time we use the absolute value is when it's odd and there's nothing else to multiply it by. And when the result is odd. Is that okay? Okay, questions? Okay. You try the next page. Pause the recording.
Absolute
Okay, absolute value of x to the 7th. Good. Rad x to the 15th. What does it simplify to, Edward?
X to the 7th, rad x.
Good. Okay, number x to the 16th. Rad x to the 16th. Anthony?
X to the 8th.
Good. X to the 17th. Rad x to the 17th. Sophie Welsh.
X to the 8th, rad x.
Good. Okay, next one. X to the 18th. Let's go. Chad.
X to the 9th.
We say absolute value of x to the 9th. Good. Next one. Next one. Let's go. How about Miles?
X to the 9th, rad x.
Good. Okay. Next one. X to the 20th. Let's go Harrison. Good. Sargis.
X to the 10th, rad x.
Good. Next one. Let's go to. How about Shayna? What did I do here? What did I do here? What do I do here? What do I do here? Look at the relationship. X to the 11th is the number. Now, do I place absolute value or not? Why? Because it's odd and there's nothing else here to multiply it by. Okay, so we're just dividing it by 2, Shayna. Okay, next one. Shayna, go.
X to the 22, rad x.
Okay, and what does that simplify to? That should be x to the 11th. Keep going. Yep. Keep going. X to the 24th. Go. Just give me the answer. Good. Answered. Keep going, Shayna. X to the 12th. What? Yep. Do you understand? Okay. So, you guys got it? Okay, next one. Noah.
X, no, the absolute value of x is something.
Good. Okay, next one. Jackson.
X to the 42nd.
Good. Next one. How about Anna?
X to the 50th, rad x.
Yep. Okay, next one. Next one. Jack?
X to the 51 rad x.
Yep. Okay. Because we're doing x to the 102nd times rad x. The square root of 102 would be 51. Okay. Next one. Alex. Go to your closest even. Yep. Okay, 250. At first I would go x to the 250, and then we go, right? X to the 252. Okay. And then I have an x. And what does it become?
X to the 126, rad x.
Yeah. Do you understand why?
Yeah, because you're, yeah, I understand.
Okay, so you go to the closest even underneath it. Does that make sense? I don't go to 250, I go to 252.
Okay.
Closest even number. Okay, now, what about the next one, Alex?
Oh, God. So fast. 241.
Yeah?
But since it's odd, is it in the absolute value?
Yes, it is. I saw you feed her the answer. You're not helping. Okay. Okay, so now we're going to talk about the domain. On your test, I asked you for the excluded values. Values x is not allowed to be. That's a different question than what is x, what state the domain. When we say state the domain, we want you to tell us what is x allowed to be. It's allowed to be any real number. So when I say x, state the exclusions, don't tell me what x is allowed to be. Do you understand? Exclusion means not allowed to be. Okay, state the domain for each root below. First of all, where do the numbers come from? What number system? X is an element of the reals. X is such that x is an element of the reals. Now I'm asking the domain question. What is x allowed to be? So, and what is x? What's the big granddaddy rule for radicals? Yes. Can't have a negative in there. So where do my x's? What must it be bigger than? 0. Greater than or equal to 0. Because 0 is a perfect square. 0 is really my boundary mark for radicals. It can be 0, it can be 1, it can be 2, it can be 3, it can be 4, but it can't be negative 1. Can't be negative half. All right, so we know that in number 2, we know because it's a radical, it has to be an element of the reals. Okay? When you get an expression like that, you have to set it to the boundary. X plus 4 is greater than or equal, has to be greater than or equal to 0. Do you understand that? So I subtract 4, x is greater than negative 4. So in addition, x is greater than or equal to negative 4. Don't just say greater than negative 4. Say x has to be greater than or equal to negative 4. Okay? Is that clear? So try number 3. Go. Pause the recording. All right, let's check our work. Okay, we know it's an element of the reals because it's under the radical. We can't have any negative radicals. And then we set the expression greater than or equal to 0, and we get x. Also, x is greater than or equal to 5. So it can be equal to 5. Are you clear?
Yes.
Okay, it doesn't matter how extensive it is under the radical. All right, so again, what am I doing here? Nadine?
X is such that x is an element of the reals.
And then what do I do with that 2x?
You put it.
Set it.
You set it greater than or equal to 0.
Yep. And I divide and I get my x alone. Doesn't matter how fancy the equation is, solve for x. So x is greater than or equal to 0. Also has to go with that. Okay, I do the same thing for this two-step expression. Set it greater than 2, greater than or equal to 0. Add 1, get your x alone. Divide by 5. X is greater than or equal to 1/5. Are you clear on how to find the domain? Okay. Yes?
Is it always greater than or equal to 0?
With a radical, it is. Just like when you have a fraction, the big rule is thou shalt not divide by a 0, so whatever gives you a 0 in the denominator for radicals. Now, something like this, all we're doing is evaluating, doing our order of operations under the radical. So I just substitute. 3 squared is what? 9 minus, I get minus 8 times negative 2. Look at this. Negative 8 times negative 2 is plus 16. Do you see that? 9 plus 16 is 25. And the square root of 25 is 5. Jack, do you remember what that's called? The b squared minus 4ac?
Me?
It has a special name. But we'll get to it in chapter 13. Yes, do you know what it is? It's called the discriminant. Okay. Anyways, so we're just doing order of operations. We will get to the discriminant later. But for now, you're just doing your order of operations. Okay? Now, if we ever get, like number 3, when we're solving something, and we get to this point where we have a negative under the radical, what are you answering? It's not a real root because it's not part of the real number system. Do you understand? Okay, there is no real root for that. Yes, there's a root, but there's no real root. The root we find in algebra 2, but we're not finding it here. Right now we're into the real number system. Yes?
So if you find that, you don't go on and you just write no real root.
Yep. Anytime. As soon as you get a negative under the radical, that's where you go. Okay. Well, we've been looking at the square root of x squared. A monomial is the absolute value of x. Well, what happens if we have a binomial? What is the root of it? Yes.
It would equal n plus 1.
Close.
N minus 1.
No, m plus 1 is correct, but I have one result. Sam?
Absolute value of n.
Yes, the absolute value of n plus 1. Because the binomial, I have one result, right? It's to the first power. This is to the first power, this whole thing. So because it's to the first power, I need to surround it by that absolute value. Does that make sense? Okay. So what would number 1 be? Number 1. Jackson.
X minus 4, the absolute value of x minus 4.
Yep, because the binomial is to the first power. Number 2, please, Alex.
Would it be x plus 3?
Nope.
Oh, 2x. I meant 2x plus 3.
2x. Okay, but it's a binomial, so when I pull the root out, it's to the first power. Okay, what you're not understanding is this means this. This means, oops. This one right here, it means x minus 4 times x minus 4, right? When I pull it out, I've got it to the first power. We said anything to the first power, the odd result, we will put into absolute value. Does that make sense?
Okay.
So what will the next one be?
Would it still be, well, 2x minus 3?
You're very close, but it's in the absolute value because that's a binomial to the first power. So what will the next one be, Alex?
Okay, would it be y plus 5 in absolute value of y plus 5?
Good. Plus?
Or minus?
Okay. Okay, now, what do you think we do for the next one?
You have to factor it out.
What is it?
X minus 3.
So this is the same thing as x minus 3 squared. So what would it be?
Absolute value of x minus 3.
Good. And then the last one,
Oh, it would be x plus 5,
which would end up being the result?
plus 5 in absolute value.
Absolute value of m plus 5. Yes. What was your question? Did you have a question, Nadine?
I had a question, but because you wrote 2x minus 3
Okay, no, I screwed up. All right, so now, why does all this matter? Because of this. So far, you've only had one method of solving for your quadratic, okay? We have said that if an equation is in balance, the scale will stay balanced as long as whatever I do it to both sides. So in this case, I have to keep the scale balanced. I could add 2 to both sides. I could divide by 2. Well, since I have a quadratic, the inverse operation of squaring is to what? Yep.
Don't you put a radical on both sides?
Yeah, we root it. And we're going to root both sides to keep it use our property of equality. So what is the square root of x squared, Jack? What? To the absolute value of x, because it's to the first power. And the square root of 9 is 3. You see how we've been doing this in pieces. So now, to lose the absolute value, that means two possible solutions. We can account for the positive and negative. So to lose it, I set the opposite number to plus or minus. Okay. Okay, so now, does everybody understand? Now, I don't want you to skip these steps. I want that in your work. Okay, so what am I doing to the first, what am I doing here, Jack?
Rad both sides.
Take the radical of both sides. Okay?
X, absolute value of x equals 6, and then x equals plus or minus.
Perfect. Questions? Okay? Number 2. Why don't you guys try that on your own? Pause the recording. Okay, what am I doing to number 2? What are we doing? Alex?
I read a rad both sides.
Okay. Then?
Then it's going to be absolute value of n equals 13, and then n equals plus or minus 13.
Perfect. Okay. Now, doing the same thing. Take the root. I say we take the root. We really don't say take the rad. We call it a rad, like the answer is rad. We say root both sides. Root both sides. Now, here's the good thing. When it's an irrational number, we leave it in the radical. You don't have to tell me the square root of 7. We leave it in there. It's more accurate inside the radical. So, the square root of y squared, Jackson, is what?
The absolute value of y.
And the square root of rad 7 is still going to be rad 7. Then to lose the absolute value, I just set it equal to plus or minus. Okay? Now, what about number 4? What do you think we do first, Anthony?
For number 4, you're gonna add 6 to both.
Right, get the quadratic alone. Remember, m squared is the quadratic. Get it alone, isolate it. If you're using this, isolate it. Now you can see, if I were to move 7 over, I can't use the zero product property, right? Minus 7, I would get m squared minus 13. So what this does, it allows us to solve for m. So add 6 to both sides, I get 13. Don't be rude, just root it. The absolute value of m is equal to the square root of 13. So m is equal to what, Rachel?
M is equal to plus or negative rad.
Good. Questions? Okay. Next one, what do you think we do? Jacob Zhang.
Add 20 to both sides.
Good. Next step, Jacob.
And then divide by 3.
Good. Now,
And then we rad both sides.
we root both sides. We don't rad both sides, we root both sides. That's the verb.
The absolute value of y equals to 4.
Good.
And then y equals plus minus 1.
Good. Okay. Doing the same thing here. Divide by 2. When I'm left with x squared equals 10, it's okay. We can leave the 10 under the radical. X equals plus or minus 10. Okay, next one. What am I doing? Jack?
Minus 30 from both sides.
Okay.
And then
Next.
divide by 2.
Good.
And then
Root. So are we going to root both sides? And what's my answer?
y equals.
Hold on. Freeze. Nobody moves, not a chair.
Value of y equals plus or minus radical 7.
Anna?
It's no solution because we put it in a radical.
Eyes up here. You're not dismissed yet. You cannot square root a negative. There's no number times itself. Hold on. You're not done. So, Stop. I said freeze, don't move the chairs. If this is left under the radical, okay, you say no real root. Okay, now what happens if I have this? Chad, I'm wondering what's going on. Okay, Anna.
Well, you're gonna put it under the radical, and then
You're going to root both sides. Everybody say root both sides.
root both sides.
Okay.
And then
Shh.
you're gonna put y plus 1 in the absolute value.
Hold on. I'm waiting. Okay, we're going to put y plus 1 into the absolute value. Now what? To lose the absolute value, you should be writing this. You need this example. Go on. To lose the absolute value, what do I do? Always the same. Yeah.
Split it up.
Not yet. It's always the same. Yes.
Y plus 1 equals 4, negative 4.
Plus or minus 4. To lose the absolute value, you have to move it over to the positive and negative result. Then I do my minus 1. I can do 1 plus 4, 1 minus 4, and we get 2 solutions. You got it? All right. Pause the recording. Try the next problem. Now check your work. And that's the lesson.